The ocean is a beautiful place. From above the water, it contrasts with the sky in such a way that brings out a natural beauty that few things can rival. But as you travel underneath the water, that beauty distorts. Not for everyone, though. A unique tribe native to Thailand has developed the ability to refine their vision in the water. However, this isn't exclusive just to them. With training, even you, young teenagers, could develop this ability. But who is this unheard of Thailand tribe that has learned to see the beauty of the ocean?
The Moken people are semi-nomadic people who live in the Marcoy Archipelago, a group of about 800 islands that are laid claim by both Burma and Thailand. They are believed to have migrated from southern parts of China to Thailand, Burma, and Malaysia approximately 4,000 years ago. They traditionally moved from island to island through the use of flotillas, which are small warships depending on factors such as subsistent needs, wind patterns, security concerns, and diseases. Because they're historically rejected outside technology, they harvest the sea's goods through more traditional methods, rather than through the use of masks and scuba gear. They gather tiny shellfish along with other foods from seafloors as deep as 75 feet. But how is this relevant to AP biology?
This topic is relevant to AP biology, especially considering that we, adolescents, could develop this unique physiological trait. We're researching to understand how these children are able to have their bodies undergo such sudden changes that give them an advantage in their given environment. What they have obtained is a developmental trait that is expressed if an adolescent spends enough time in the water while looking through it with their naked eyes. How are they able to adapt so quickly? Evolution itself takes many generations to accomplish the smallest of trait changes, so how is it possible for children to suddenly enhance their vision underneath the water? So would this be passed via genetics within the tribe, or does this trait lie dormant within all of us?
Hard to determine whether the Moken children's ability to see underwater was due to a genetic abnormality, or if their unique ability was simply a result of the fact that they dive into the water looking for shellfish and other foods every day. A test had to be done. So European children between the ages of 8 to 13 were brought into the islands and were told to dive into the water and try to conclude the direction of the gratings, or black and white stripes, of various widths that were displayed in the water. Each time the children managed to correctly identify the direction of the pattern, the scientists would use a finer grading or thinner stripes. After about 11 sessions across 1 month, the European children attained some of the same underwater accuracy as the Moken children. But how is this possible?
Some of the possible explanations require the eye to have undergone drastic changes in morphology. For example, if the Moken have evolved a flatter cornea and a stronger lens, they would achieve good resolution on land and improved resolution when diving. Another possible explanation is if they have become severely myopic, this would improve vision underwater but result in blurred vision when on land. And a third is if Moken children simply have the ability to accommodate more than normal, this too would improve underwater vision. All three of these strategies are known to exist in the animal kingdom and are actually put into use. Examining on land the eye's corneal curvature, refractive state, and accommodative power in both groups of children, these results have shown that on land the Moken do not differ from the European children in any of these respects. Their keratometry values are well within the normal range in both groups as well. The majority of the children are slightly hyperoptic with refractive errors ranging from +2 to -0.5D, and there is no difference in the accommodative range between the two groups of children. In conclusion, all results are well within the normal limits for children of that age range. But when underwater, the Moken children have been found to have greater sensitivity to contrast at all spatial frequencies tested, p less than 0.05 at the lowest frequencies, down to p less than 0.0001 at the highest frequencies. Another finding is that the pupil of a Moken child, A, is smaller than the pupil of a European child, B. Both images were taken with infrared light. These results show that indeed the changing of the pupil size is what allows them to see with clarity underwater. Looking at picture A, according to simple geometry, the diameter of the blur circle X on the retina is d f minus a divided by f, where d is the diameter of the pupil, f the focal length, and a the distance to the retina from the lens. Looking at picture B, the solid line shows how the size of the blur circle on the retinas of Moken children changes with their accommodative response if one assumes that pupil size stays constant. And if we assume that European children do not accommodate underwater, their blur circle diameter is 1.71 millimeters. The Moken children need to accommodate 15.7 D to reduce the diameter of the blur circle to half this value, which will be 0.85 millimeters. When the Moken children dive, their pupil size decreases from 2.33 millimeters on land to 1.96 millimeters underwater. And in order for the size of the pupil to change, the different parts of the eye have to work together, much like a well-oiled machine.
Now, there are two parts to this adaptation, the pupil accommodation and the lens accommodation. For the pupil accommodation, more commonly known as pupil dilation, there are two fibers that control this. The first is the sphincter muscle fibers that line the outside of the pupil, so when they contract, it causes the pupil to contract. Now the other muscle fiber is the dilator muscle fibers that line the edge of the pupil and go to the edge of the eye. So when those contract, it causes the pupil to dilate. Now, this accommodation is based off the pinhole effect. So as your pupil contracts, the depth of focus is increased by the blocked light that was scattered to the periphery of the cornea. Now, the other part of the adaptation, which is the lens accommodation, is based off the changing lens shape. Now, the stimulus for such an action is an out-of-focus image. Ciliary muscles that contract cause the curvature of the lens to increase. This increased curvature restores some of the refracting power that is lost when underwater.
Overall, the psychological trait expressed by the children of the Moken tribe is not a genetic anomaly. It is a natural trait that lies dormant within all of us. It is expressed once the refracting power of the lens is decreased due to water contact with the cornea rather than air contact. It then causes the lens to become more convex to increase the refracting power, attempting to restore the status quo. These are the inner workings of the Moken people's eyes who have developed this ability. But now the Moken people have moved inland because of the devastating 2004 tsunami which crushed their village. Now it is believed that these children that were a part of this experiment are now the last of the Moken tribe to possess this extraordinary trait.